Okay, so this next standard, you can use the mean and standard deviation of a data set to fit it to a normal distribution curve and estimate population percentages. So number one is going to fit with the empirical rule. The empirical rule states that, excuse me, 68% lies within one standard deviation of the mean, and 95% lies within two standard deviations of the mean, and 99.7 lies within three standard deviations of the mean. So that's everything you've done up to this point. Excuse me. It says, suppose the heights in inches of men and gives a specific age range in the United States are normally distributed with a mean of 89.3 inches and a standard deviation of 2.92 inches. Part A says to label the normal curve with three standard deviations above and below the mean. So on Friday we learned that the mean always belongs with 0. So I'm going to write 69.3 and try to write it really small and neat, which is hard for me. 69.3 goes with 0. And now it tells us that the standard deviations, or each one of these lines, will represent 2.92 inches apart from the next line. So if we start on a calculator, we can start with the mean, and let's go up to the right. So we're going to add 2.92, and this next line coming down will be 72.22. Add it again. We have 75.14, and your final time will be 78.06. Now I'm going to go with the negatives. So instead of adding the standard deviation, I'm going to subtract it. Start with the mean and subtract 2.92, 66.38, subtract it again, 63.46, and 60.54. So part A is done. Part B says to calculate the z-score, and we're going to calculate the z-score using a data point of 75.14 inches. So I do need you to show your work. So a data point, subtract the mean, divided by the standard deviation. And I have a z-score of 2. Part C says to find the percentage of men, and it gives the specific age range that's associated with this problem in the U.S. that are at most, and it gives a specific height. So at most, that means you go up to this point, but you never will exceed it. So we're talking, let's find where 75.14 is. It is right here. So we want to know everything up to this, but not beyond it. So there's a couple of different ways to calculate that. Remember, you need to have these memorized before tomorrow. One way would be to add up, please don't do this, 0.15, 2.35, and add up all of these, and that would give you your percentage. But a quicker way is I see there's only 2 percentages to the right. We learned Friday that the percentages under the curve add up to exactly 100%. So can you start by adding these up? 2.35 and 0.15 add up to 2.5%. So if we take 100% and we subtract what's over here, we end up with 97.5%. Now, could we have also achieved that number by adding up everything to the left of 2? We could have, but this is just a quicker way to do it. Okay, part D. Find the percentage of men in the United States that are between 66.38 inches and 75.14. So I want to just do this. Okay, 66. All right, so I want to know this region. So add up the percentages you see for me, please. And I come up with 81.5. Let's not round it. 81.5%. Okay. So before I do part E, I want to give you a very simple example. Everybody pay attention. You ready? If this said, by the way, can you please change this? This is a mistake I saw in previous hours. This should be 0.46. There's more confusion with this, so I first want to give you an easier answer. If it said that you have a group of 550 men, and you want to know how many of those men can you predict will have a height that is less than 69.3 inches. This is not this problem, but I want to start with an easier one. You have this many men, and you want to predict of these men, how many of them will have a height of less than 69.3? Well, we know that 0 is like the 50% marker. So less than 69.3 inches would be 50%, correct? So 50% as a decimal is 0.50. So please take 0.50 times this many men. And what would be your answer? Do you agree we would have 275 men that we can predict would have a height of less than 69.3? Okay, we're going to do the same thing. It says, okay, so we have this many men. Again, it gives the same age range. It's from the same area of the world. And how many of them will we expect to be taller than this many inches? So let's find where 63.46 is. 63.46 is this line right here. So yes, I could add up everything to the right, but I think it's faster in this case, and there'd be nothing wrong with that. I think it's faster in this case to calculate to the left. So when you add up 0.15 and 2.35, you end up with, remember that underneath the curve, it all adds up to 100%. So I have 100% minus 2.5%, which equals, so we can assume that 97.5% of the men from the U.S. in this age range will be taller than this height. So let's take this percentage, and we have to turn it back into a decimal, and we're going to take it times 550 men. We can't have like half of a man, so we would expect for there to be about 537 men out of that group that would have a height of that would be taller than 63.46 inches. And the last one is a pretty simple one. It says 72.22 inches is how many standard deviations above the mean? And it is 1 standard deviation above the mean.